Hello everyone, welcome back to another Seaborn video. So this time I'm doing bivariate analysis using the Iris Dataset. So it's available on Kaggle.com. Basically, the dataset is 150 flowers, and the people that made it measured their properties like the petal length and the petal width in centimeters, and then they're all like recorded in the rows and columns. So I imported that, and now I'm going to graph it out and explain why you would use a joint plot from Seaborn. Alright, so first, let's go into the code. I make the figure, set the size, then I create the graph. So it's a joint plot, and then these two are the variables. This is in the x-axis, this is in the y-axis, and then data, I named the data set, or I named the data frame data when I imported the data set. And so you just put that right there. The kind will be KDE, which stands for kernel density estimate. And KDE is like this kind of distribution graph right up here, outside of this main I don't know how you would call it, like I don't know, isograph. But anyway, so the higher it goes, the more frequent the values around that region are. So like there would be a big group over here, around like 0.2 maybe for the petal width centimeters, and then about right here at 1.5 there's also another big group for the width, and then the length, there's a big group around here at about, I'd say 5 centimeters for the length, and then this might be like maybe 1.5 centimeters, give or take. And so if you combine them into one graph, and you can do this in like a scatter plot mode, then the closer together all the points are, or the denser they are, the darker it becomes. So you can see that there's a very dark blue circle over here, and then a dark blue kind of ellipse over here. So those would be your two main groups, and you can see it kind of looks like mitosis. When the cell splits apart, it becomes like two new cells, except I don't know, this one might have a mutation or this one might have a mutation, but let's not go into that. That's just like a detail about this specific data set. But sometimes you can tell a lot about the data set just from looking at the joint plot, the relationship of two variables. So if you go more in depth, you can get the R value. So you do the correlation between the two columns with dot core, and then that'll give you Parson's R. So here it would be 0.96, about, slightly more. So that means there's like a strong positive correlation between these variables. Then you can give it like a title, and that's just for the aesthetic, I guess. So yeah, I think the joint plot is very useful when you're doing bivariate analysis, especially when that data is in kind of like semi-normal distribution. Like you can see this one has like two normal distributions on top of each other. So it's still kind of useful though, because you can see there are two major groups. And you can see where the values are most densely packed and how far out they go. So that's what I would use a joint plot for. Thank you guys for watching this video. Hope you guys learned something new, and see you guys next time.